We're going to be talking about slope fields. A slope field is a visual representation of the solutions to differential equations. You'll be expected to, at the end of the video perhaps, maybe after the first couple days of working with slope fields, that you could be able to do all of these things. I'll let you read those. First thing we got to do though is we've got to figure out and make sure that we know how to draw slopes. The slope of 1 is a 45-degree angle, 2 is a little bit steeper, 3 is steeper, 4 is even steeper, and 100 is almost vertical. And then slope of 0, a slope of -1, a slope of -3, slope of -10. And so if you can do that, you can create a slope field. So let's take a look and see how it works. Here we have a differential equation. It's a differential equation because it has a derivative in it. And this is a first order differential equation because it's just dy, or y prime. And so if dy dx is equal to 2, then the slope of y is always 2. If the slope of y is always 2, then if x is 1 and y is 1, let's say, the slope is 2. That would look about like that. If x is 1 and y is 2, the slope is still 2. So the slope is 2 no matter where you are on this slope field. So draw the slopes of 2. And one good way to think about this of drawing a slope of 2 is count up to and over 1 and then just kind of aim at that other dot over there. So aim at the dot. And once you draw one slope, if you're drawing the same slope, then make sure you draw them all the same. Same slope. So this is a slope field that would indicate the slopes of all the points on the solution or on the particular solutions to the differential equation. So that's a slope field of 2, where all of the ordered pairs generate a slope of 2. Well, that's not very exciting, so let's look at another one. Here we have a slope field, or they're all slope fields. Here we have a differential equation that represents dy dx is equal to x plus 1. So if dy dx equals x plus 1, then we can make an xy prime chart, because this here is y prime. And so if we make an xy prime chart, if x is 0, y prime is 0 plus 1, which is 1. If x is 1, y is 2. Y prime is 2. X is 2, y prime is 3. If x is -1, y prime is 0. -2, y prime is -1. Okay? So we can see here that y prime does not depend on y at all. So y prime only depends on x. So when x is 0, y prime is 1. So we can see all of the derivatives, all of the slopes on the slope field are all 1 when x is 0, independent of y. Okay, so that's going to be a clue for you when you go to match up a differential equation with a slope field. And when x is equal to 1, the slopes are 2. So we're going to try to aim at that dot right there. Slope of 2, slope of 2. We know how to draw slopes of 2. And then slope of 3, so draw it even steeper. As long as you show differences in these, and these are not that much different, but you can see that they are. So slope of 1, slope of 2, slope of 3, just show that they increase in slope as you move from left to right. Then when x is equal to -1, we know the slope is 0. Those are the easy ones. Slope of 0. And then when x is equal to -2, we have a slope of -1. So the -1s and the 0s are the easiest ones. Those are the 45-degree angle ones. And this would be your slope field. And let's think about this for a second, because this is kind of interesting. If dy dx is equal to x plus 1, then let's do this right up here. Then dy, let's separate the variables. dy is equal to x plus 1 dx. Okay? And then when we take the derivative, or the antiderivative of both sides, integrate both sides, we get x squared over 2 plus x plus c. Well, what does that mean? Well, if x is 0 and y is 0, we have this slope field that goes right through, or this particular solution that goes right through there. If y of 0 equals 0, that would be our initial value to this, for this differential equation. So that would be an initial value problem. So if y of 0 is 0, it means that c equals 0, because you let x equal 0 here, and we just get y equals x squared over 2 plus x. If you factor out an x, you get 1/2 x plus 1. So we get an x-intercept of 0, and we get an x-intercept of 1/2 x equals -1, x equals -2. Okay, so we get an x-intercept of a -2 and of 0. And if we draw the solution curve through there, we would see the solution curve looks like that. Well, if y of 0 is -1, we would have a solution curve that went through -1, and would go up like that. This is the family of solutions to the differential equation. And the slope field shows the slopes of the solution curves to the differential equation. And the particular solution we get when we have an initial value. Okay, so that's in a nutshell how to draw at what slope fields are and how to draw them. So we'll go a little bit quicker here. I won't show every single dot, but I want to show you really how to find the different slopes. And the bottom line is just make an XY prime chart. Okay, XY prime chart, start with 0, Y prime, oh, look, it doesn't depend on X, does it? So we need to make a Y prime chart because Y, it depends, the Y prime depends only on Y. So when Y is 0, Y prime is 0. When Y is 1, Y prime is 2, Y is 2, Y prime is 4, -1, -2, -2, -4. Okay? So when Y is 0, now all the slopes are 0 when Y is 0. So we go this way. So notice when all the slopes are the same, when you go from left to right, it means that the differential equation has no x's in it. Okay? The differential equation, what's on the right side, is independent of x when the values in the slope field, when the slopes in the slope field are all the same. Now notice over here, when the slopes in the slope field are all the same up and down, it means there's no y up here. Okay? Because the slopes depend on x. As you move left to right, the slopes change. Here, as you move up and down, the slopes are going to change. When y is 1, the slopes are 2. All these are 2's. Okay? And then when the y is 2, the slopes are 4. So to make those really steep. When y is -1, the slopes are -2. I'm going quick. And when y is -2, the slopes are -4. That's really steep. You're never going to have to draw a slope, something like less than -4, bigger than 4. Now, this is where it gets a little bit more fun because we have the slope field is dependent upon both x and y. So when x is 0 and y is 0, y prime is 0. Okay? When x is 1 and y is 0, y prime is 1. When x is 2 and y is 0, 2. Okay? When x is -1, 0. And you get -1. -2, 0, -2. And then what happens when we move up? So yeah, it does become a bit of a pain, but you start to see patterns, and then it gets a little bit easier. So when x is 0, so we got to go way down here like this. When x is 0 and y is 1, then we get 1. And then we get 2. X is 1, y is 1, we get 2. So we can, once we see the pattern, we can move away from the chart and move right to the slope field. 1 plus 2 is 3. -1 plus 1 is 0. -2 plus 2 is 0. 1 and -1, 0 and 0. And you just keep moving along like that. So 0 and -1 is -1. 1 and -2 is -1. And you go, oh, there's a -1 right there also. -2 and 1 is -1. And then what about the -1 and 2? That's 1. And then 2 and -1, that's 1. And there's a 1 over there as well. And then we have, what do we have over here? -1, -1, that's -2. -1, -2, -3, -2, -1, -3, -4. And there we have our slope field. All right.